All right, it is 1:02 p.m. Eastern Standard Time, and we will begin. Hello and welcome to this edition of an AI for Finance webinar. We have two very exciting guests today, Diego of Algorithmia and Rajiv over at BNY Mellon. Rajiv, as you may have noticed, recently joined BNY from State Street, so snaps for Rajiv. And today's conversation will be moderated by Cormac, who works at Algorithmia. And so without any further ado, I'm going to kick it over to Cormac to get us started. Take it away, Cormac.
All right, thanks, Michael. And hi, everyone. Welcome to today's webinar. As Michael mentioned, my name is Cormac Foster. I will try to speak as little as possible so our illustrious guests can do their thing. Welcome to Becoming an AI Company, from Business Problem to Productionized Model. Little housekeeping note, if you have any questions, please ask them in the Q&A window. If we can't get to your question during the webinar, we'll follow up with you after the session. We'll have a Q&A section at the back end of the webinar, and we'll also try to sprinkle them in as it makes sense through the webinar, but we will generally try to stack them toward the back. So if you ask your question and you don't get an answer right away, please don't worry, but please do ask. I'd like to do another quick introduction of our speakers, let them tell you a little bit about themselves so you can match the name to the voice as you're listening. I'll start with Diego Oppenheimer. Diego, a quick little bit about you.
Yeah, so my name is Diego Oppenheimer. I'm the CEO and founder of Algorithmia. For those of you who've never heard of us before, so what Algorithmia specializes is we help companies with our platform deploy machine learning models at scale and manage the full life cycle of those machine learning models. We mostly work with large Fortune 500 companies, but also run algorithmia.com, which is the largest model marketplace in the world. Before that, I spent time building data analysis tools at Microsoft, including Excel, SQL Server, and Power BI.
Great, thank you. And Rajiv?
Hi, my name is Rajiv. I'm currently Director of Data Science at BNY Mellon. Before that, I was with State Street working on some AI and ML exciting projects where we were looking at alternative data sets and how we can use those to gain some insights, especially for portfolio managers and risk officers. My experience is in financial services. Before State Street, I've done some front office, middle office, and back office work. So all across the board.
Great, thank you. So we're going to actually start out with a poll just to get a pulse for the audience. I'm wondering how many data scientists your company employs today. If you're not quite sure, give it your best guess. We'd just love to see where you are. And while we're waiting for those results to come in for about 30 seconds or so, Diego, do you have, is there a normal, what does a typical, company enterprise have in terms of data scientists?
I really think it depends on kind of where they are in their maturity as an organization. And, you tend to see a lot of new data scientists in the sense that you have kind of old classifications, so it might be known as quants or researchers or kind of like advanced data analysts in certain organizations that are now, increasing their statistical background and their programming abilities, and they're now considered data scientists, or to organizations that have never really actually approached data in any way. And so they tend to be, they started hiring. You start with these small teams. I would say, 10 to 11 to 50 is probably the where I've seen the majority of the Fortune 500 fall into, but you have to start somewhere, and so it's pretty rare. It's pretty common to see the 6 to 10 period as well.
Okay, that actually seems to be pretty reflective of the folks on the call right now. Rajiv, anything to add to that before we move along?
I think it's pretty much what Diego had. That's what I have seen typically, or how I have built organizations. Anytime anything comes up, you look for folks internally, basically on the quant side. That's where the starting point is. You gather the people, get them started, and you start hiring, right? So the starting would be depending on how mature the organization is. You start a team of five to 8 people, and then you grow up from there.
Okay, great. I'd like to just start, before we start talking about the differences, that are specific to financial services. I know Diego spent a lot of time talking about this, kind of the differences between machine learning and what we've been doing in software development for the last 20 or 30 years. So Diego, any thoughts on that and where what we've been doing starts to break down?
Yeah, so I think there's a fundamental difference, and I kind of joke around because I say, if you look at the old software development lifecycle and you kind of look at the new approach with machine learning and data science, like it's same but different. And I think it comes down to, like, for most part, our systems have really been specialized on deterministic code. So, certain path, rules, and now we're actually, dealing with probabilistic code. So things that, like, while the code itself never changed or the components never changed, the results are changing as new data comes in and out. And so I think an approach to that has to take that into account. And so you have a lot more of these new monitoring systems and availability systems that are, they're slightly different in terms of where traditional development versus kind of machine learning development. The other one is around the pipelining and the amount of, like, models don't live in isolation, but they're actually usually as part of machine learning pipelines from data in, pre-processing, post-processing, and that's not something that you see as common in traditional application development.
Rajiv, anything to add there?
Yeah, so I think like traditional development, it's grown like over the past few years, right? Especially with the DevOps kicking in over the last few years, and the agile thing coming in, right? So it's become more iterative, but there are some of the basic differences, right? So you look at traditional development, it's basically develop, build, test, and deploy, right? So that's typically the cycle, and you iterate over it, right? So machine learning cycle is a little bit different, right? So and data is, which Diego touched on, right? So data is a big part of it, right? So you end up like ingesting the data, then cleansing it, figuring out what data you need, what is right and what is wrong. And then there's a whole process of figuring out what models are right for it, training the models, right? It's more dynamic and more involved. So the same kind of structure, which is in traditional development, does not fit into machine learning. It is a little different. And I think people are slowly figuring that out, or they're recognizing it, but still I think there are a lot of gaps. Typically you would go into organizations and they try to fit the traditional application development and bring it over to the machine learning, and they start realizing that it's not same.
Okay, great. Now, kind of on that same subject, a lot of you may have seen this Google slide before. Only a small fraction of real-world ML systems is actually ML code. The same, I guess, can be said of software development generally. Like you mentioned, we've got this whole DevOps infrastructure around everything. But, like, what of this? Do we have established processes for this right now? Like, what tools are we using for it? How does this flow, and who's really responsible for all of this? Diego?
Yeah, so I think we're starting to see, if you think about the steps that are needed, right? So you can't really start with any ML code until you've collected data, and then once you've collected the data, you have to kind of clean it, verify it, have systems for it. Then you can actually start building ML models. That once you've actually started building ML models is when you start kind of like figuring out, okay, now I need to get a bunch of GPUs and I need resource management. And then I get to the point where I'm like serving and monitoring. So if you think about those being the steps, I think what we're seeing is that, like, we've gotten to maybe the point where we're seeing systems around data collection, data verification, a big part of the kind of big data push, over the last, I would say, almost decade, has been about, well, how do we collect this data? How do we get to all the data in one place? The building of data lakes, collecting building robust ETL systems that are going to get us there. And so now it's like, okay, we've finally crossed the barrier of like, okay, now we have all of this available to us, what we're going to do. And that's where you can actually start really doing machine learning. And so I think the processes and the maturity at the stages are coming as the industry gets to those points. And so now it's really about, thinking now that people are actually doing machine learning in production, is a lot of the processes and tooling, machinery is coming around. How do we build models? How do we build models in a repeatable way? How do we serve models in a repeatable way? How do we productionize models? And those questions are starting to come, but you kind of had to have the data collection, data verification pieces, quote unquote, solved to a certain degree from an industry perspective before you can even touch that.
Great. So Rajiv, you have been on the front lines here actually doing this. Does this look roughly accurate to you, or is it, can you, like, how do you say, okay, now I'm going to do ML and let's just build some models and go?
Yeah.
What does that look like?
Yeah, so this is, I mean, this really, kind of captures where a lot of companies are, right? In the sense, like, so typically when people think about data science, machine learning and all, right? So it's all about model. You get like some data from here, some data from there, and put together like a quick model and bait. But you can't take that thing and scale it up and productionize this, right? But everyone, what everyone does not realize that, like, to productionize the whole machine learning, it's not that single model. There's a whole platform around it, right? Which is actually depicted in this picture, right? It's just not about building a quick model with some sample set, right? So you have to have the right data collection, right ETL pipelines in there, right way to monitor the data, to visualize it, right? So infrastructure monitoring, versioning the models. There's a whole platform ecosystem which has to go along with it if you really want to productionize that, right? And that's where I see, or where I've seen the challenges have been, right? It's very quick to put together a model, but to actually take that model and productionize it, that's where I think the gap is, and we see that structured approach is still not built yet.
Great, thanks. We have a question that just came in from the audience, which I'll read here. It says, we have a fairly automated DevOps system in place for a traditional fintech SDLC. We have a large opportunity to ingest ML into our business capabilities. Is there a concept of ML ops? And if so, what's a good way to understand it, ML ops, using DevOps knowledge that's available in the industry? Diego?
Yeah, absolutely. So there is a concept of, of ML ops, and I think it's kind of where I was alluding to when I started. I say same but different. A lot of the concepts, programmability, automation, repeatability, alerting systems, logging, one thing that I describe as loosely coupled systems that are tightly integrating. So using programmability models to be able to plug and play a whole bunch of tooling into a process. These are all things that we can borrow from the DevOps world. Having machine learning participate in CI/CD pipelines, absolutely the case. Using things like Git as part of your data science process, another place where we think that a lot of things that can be borrowed from the software development lifecycle. I think that 5 years from now, my prediction is that we won't really be talking about machine learning anymore. It's just going to be software, and it's going to just be a slightly different level of software, because really what's happening is we're just building machine learning processes and predictive models into our everyday software. And so I think what we're going to see is the adoption in a new traditional software development lifecycle of these ML toolings, and it just needs to take advantage of and just have slightly different parameters. Like, as I said, monitoring tools are slightly different. You're dealing with probabilistic code, so it behaves slightly in different ways. But I think we can borrow a lot from the traditional DevOps tools. And the fact is that we're not going to suddenly start seeing data scientists wearing pagers. When things go down. It is going to be DevOps teams that are going to continue maintaining and supporting these systems. And so having that bridge between the DevOps teams and the data scientists or the machine learning engineers becomes super important in terms of, one, educating a new crowd on, hey, these are the types of things that can go wrong, things like model drift or, different ways in which a model can go poorly, but also it's where the DevOps teams can now bring to the data science team, like, hey, this is how you think about concurrency. This is how you think about disaster recovery. This is how you think about backing up and making sure that we can provide like high levels of SLAs. And so there's a lot of learning between these two kind of, between the data science, machine learning crowd and the DevOps crowd, that they can learn from each other. But I absolutely think that we're going to be borrowing, and we see this today. I mean, without pitching, like what our platform does is actually borrow a lot of concepts from the traditional DevOps world and bring them to the world of data science.
Great. Rajiv, have you been kind of porting DevOps to ML as well?
Yeah. So I think anyone who would start, especially no one, would come in and actually build a whole new DevOps process, because people who have dealt with it, it's not easy, right, to build the whole process end to end. So even when we have done, or I have done some work in the past, it's mainly you look at the existing DevOps processes and pull pieces of it, right? So you can't fit everything as is, but the idea is to take what is applicable for machine learning data science pieces and actually put them over to the data science platform and use that, like be it monitoring, be it how we scale the system, how we scale the infrastructure. A lot of these things you can actually use on the data science side also. And I think one of the big things is that so there is a knowledge gap between the DevOps machine learning side, right? In the sense that people on the DevOps side, they are not still as familiar with the data science side as they would be on the application development side. So one of the things is to actually make them aware, make them knowledgeable about what are the things we need on the data science side, what is it different from the traditional application development, so that they can factor in those things. But ultimately, you want to actually build that team up, grow that knowledge base, because you don't want to be taking on, like data scientists should not be taking on like a DevOps piece also and running that end to end. So definitely different.
Okay, great, thank you. And to the person who just asked the question about compliance, we have a section on compliance at the end. I'll be sure that we put that one in there. Right now, I'd like to do another quick poll. We talk about deploying models into production. We'd love to hear what you're doing. And when we talk about deployment, we're actually talking about taking a model and placing it somewhere where the output of that model can be consumed, either by other models in a pipeline or by applications. So putting something up, standing up like an API endpoint around it so that other applications can access it. Okay. And while we're waiting for that, probably another 30 seconds. Diego and Rajiv, what have you seen when you go into an organization that's fairly new to machine learning? Like, is deployment into production something that comes down the line? Is it something they're thinking about at the start?
I would say we see starting to change quite a bit, but for the most part, not a lot of models in production. There's certain industries that have had certain kinds of models kind of in production. So, like banks and financial services have had, kind of traditional logistic regressions that they've been using for risk management for quite some time, and they have their processes for deploying in those. But I would argue that most of the industry is not quite in production just yet, and just getting there. And so folks are kind of figuring that out as they go.
Good job, actually, predicting the results. It looks like 40% of the folks have not deployed any models yet, so it looks like everyone's right on pace. Rajiv, any thoughts before we move to the next slide?
No, I think like that will be my perspective. So from my side, we have deployed models to production, but the path to production is not easy, right? So when we started, we were in the same thing. How do we deploy to production? How do we figure out things? But as we moved along, I think we kind of figured out or defined some processes around. There were compliance issues, audit issues, things like that, right? So it's not an easy kind of path to production, but I think a lot of people would get there, I think, over time.
Great. So on that subject, actually talking about the things that get in your way, we have some numbers from one of our surveys here. I'll have Diego talk about, and then I'd love to get a reality check from the field from you afterwards, Rajiv. Diego?
Yeah, so I mean, we've talked to a lot of data scientists, machine learning engineers, and we found that, really most of their time, and the Google paper kind of backs it, like they're not spending on building the models or training them, but actually on everything around that, everything from data collection to data cleaning to how this is actually going to go, how this model is going to go get productionized and built and deployed. And I usually joke around and I say, it's kind of like hiring a race car driver and asking them to like fix up the motor of the car. Like, probably not why you hired the race car driver. But what we do find is that the ML teams and data science teams are really asked to doing a lot of tasks which are not really, what their highest value task would be. And in those challenges, as I said, we see everything from working in traditional languages that they've not worked in to how do you deploy at necessary scale. Putting an API around the model is not a production deployment. That's just a way of calling it. And so there's quite a big gap between the aspect of, hey, I've built a model and I'm actually willing to have this model take a critical path inside my infrastructure or inside my institution.
Thanks. So Rajiv, how much data science do your data scientists generally get to do?
Yeah, so I can't vouch for these numbers, but I think the problem is there. Like what the slide highlights is the issue that data scientists do end up, and I've seen this across different teams and across different projects, is that they do end up kind of owning the full thing end to end, which is not efficient and which is not optimal, right? So data scientists worrying about how they're going to version the models, model management, infrastructure. They pretty much, they should be fully focused on actually their models, but unfortunately, the reality is a lot of times they're actually, worried about the infrastructure pieces of it, how they're going to version it and all that. So this problem definitely is there.
Yes. Okay, great. Thanks. So we've got another couple of questions coming in. I'll take one of them now. Someone says we've currently deployed two models. We have two models in place for portfolio optimization using commercial off-the-shelf shrink-wrap neural network modeling solutions. There seems to be a lot of innovation in the quant space to develop and deploy models using a SaaS mechanism. What's the best way to navigate transition from commercial off-the-shelf to SaaS?
Sure. So, I think at the end of the day, it matters on how can you achieve your use case in in the best way. So, if you have a team that can grab some off-the-shelf solution and they're building, neural nets optimizations, and that's the easiest way to deploy it. I think the question here is how can you achieve your business goal the fastest is really how to do it. And in some cases, it might be a combination of the two. One of the things that we find versus using kind of a SaaS model versus commercial off the shelf is think about when you're deploying a model, if it's just going to be used for this one task or if it's going to be used across multiple tasks inside an organization. And this is something that we kind of thinking repeatability and thinking reuse is really important because your data science resources are very, very limited, and they will be limited. You will have a hard time hiring more data scientists no matter who you are as an organization. And so when you start thinking about, hey, we're building, for example, an NLP model that's going to be extracting data from Edgar, then, that there's probably 4 or 5 different business units and teams that might want to use that inside your organization. So thinking, okay, I'm not only going to build this for myself, but also how the rest of the organization could take advantage of it. There's a lot of kind of at the corporate level, savings and speed that can be built in terms thinking about centralization and how do you build once and reuse many times. And so versus thinking about, hey, SaaS is better than a commercial off-the-shelf solution, I would argue that the better way of thinking about it is what is going to get you to the results fastest? And then once you're getting to those results fastest, what's the most repeatable and shareable way within your organization so that multiple teams can take advantage of it? And if you can answer those two questions, you can go with either. I don't think there's a strong reasoning to go in one way or the other outside of those. Now, if you have a SaaS provider that comes in and says, hey, we can run your neural nets faster, we can, our off-the-shelf solution does everything you want and you can get to your business goals quicker, then there's really no reason why not to use it. So that's kind of where I would navigate it. It's first is the use case and the success of that use case. And then the second over is how easily is this going to be reusable or repeatable inside my organization so that when the next time I have to approach this problem, I don't have to reinvent the wheel again.
Great, thanks. Rajiv, anything to add there?
No, I think I pretty much concur with what Diego had. The way I have looked at it always is what is the use case and what is the use of these models, right? Plus, you have to factor in other things depending upon the business unit and the organization you are in, the audit compliance and all those rules. can you share the data, can you share models, and all those factors go in. So it's at least from my perspective, I've never looked at it as like either like off the shelf or a SaaS base. It's purely based on what generates the maximum business value in terms of reusability, sharing it across the organization. So I think all those factors come in and play a part in here.
Okay, great, thank you. So we're actually going to, actually we have one more question that someone asked before we go to our lightning round on operations. How do you measure the success of an ML project? It's kind of a big question, but I guess if you're the person tasked with putting this together, like how do you approach it? Is there any specific way you should look at success?
Well, I think you shouldn't approach an ML project without a success criteria to begin with. So if you're trying to measure the success of a project after the project has started, I think there's already been a little bit of putting the cart in front of the horse type thing. So the most important thing with any analytics project has nothing to do with ML, but actually you can go back to the BI world and like, what is the business question that's trying to be answered? What's the business process that's trying to be optimized? What is the bottom line, change that's trying to happen? So is that, I want to increase sales, I want to reduce costs of an operation, I want to give speed to an analyst, like what is that? And then that should be the measurement that is used throughout the entire process. Because at the end of the day, the delivery of the project is all that matters, and that result is all that matters. Everything you did there was kind of like to be able to do that in that way. So that's kind of how I would approach it. To be able to measure success, you really should have a pretty good idea of what that looks like before embarking on the project.
Great, Rajiv, you're kind of on the line for these sorts of things every day.
Yeah. So this is, I think anyone who picks up the project or use cases, I think the first thing you need to understand, or you should have a very, very clear understanding on the business value it is generating. So a lot of times what I've seen is that, it's a new thing, right, which you want to do. You want to do some ML, you want to do data science, you want to do artificial intelligence, and you start pulling in a lot of these use cases, which if you really sat back and looked at it, might not generate the business value you were hoping to. So before you even start developing your models, I think the first thing everyone needs to look at is what is the business value that work is going to produce, whether it's in terms of new revenue or cost savings or whatever it might be. I think if you're clear on that piece, then it's very, very easy to define the success factor of any of these. And that's how I have measured in the past, right? So you define the business value of it. If you're very clear on what you're getting out of it, then you will know, what the success factors are.
Okay, great, thank you. So moving on to our lightning round. We'll start off this first one with Rajiv again. Who should own ML in an organization?
So I don't think there's one person who should own ML. So it is a collective, it is an organizational thing, right? So a data scientist should not own the ML, or business should not own the ML, or ops should not own the ML. Everybody is in this together. So I think it has to be an organization-wide effort to have this.
So Diego, do you agree?
Yes, I mean, I absolutely agree with this. I think the fact is ML is not a business unit. It's it's a technology that's going to affect every single business unit out there, and so it's really a question of this is going to be transformational to the business. So you have to have buy-in at kind of every level. Everything from the business users to the technology. Now the question is, is there an owner from a technical implementation perspective? That's one question. Is there an owner from a process perspective? That could be another one. But realistically, ML, I mean, this is a transformational change that goes, everything from the digital to the physical world.
Okay. So if you're just getting started, I'll start with Diego here. How should you staff up your ML team?
Well, I think you first need a leader. To start with, a leader who understands, you need the Rajivs of the world, right? Somebody who's willing to sign up for the output, somebody who's willing to own the kind of this is what we're going to achieve with these teams, and I'm signing up for that success criteria. Once you have somebody kind of owning the output and the results, you can start staffing based on what those are going to look like, right? So you kind of have that work back model. Do I need a couple of data scientists? Do I need a couple of DevOps engineers? Am I going to need some ML infrastructure engineers to build it out? But I think you always have to start with the person who's willing to own the output, because you need that person to kind of exist and drive forward what those results are going to look like.
Okay. Great. Rajiv, anything to add?
No, I think like you said, like there needs to be a champion, right? So once you have the champion, once you have your use cases laid out and you know what you're going to do with that, right? So that's where you start, right? So you like it's just not data scientists. You would need support from business ops, everyone, right? To actually help the data scientists and ML team grow. So once you have the basic framework structure in place and you start getting people out, you look for people who are on the quant side who can help on this thing.
Okay, great. Two more questions. How do you approach build versus buy when you look at this? This is kind of related to the COTS versus SaaS question we had earlier. Diego?
I think it's, it really depends on what you're looking at, right? Like, is this going to be your company's IP, right? So like, is this algorithm that you're developing, is this NLP methodology, is this like portfolio optimization model? Like, is this going to be your competitive advantage? Is this going to be then, those are the types of things that you want to think about building. Everything else, my opinion is that you should buy it. And the reason why I say that is, let's think about infrastructure and deploying models at scale. You can spend, it's great. You might be able to build an infrastructure to serve a model, but unless you're going to have a dedicated team for the next half decade or decade that's going to be continuously advancing forward that infrastructure, you're always going to be in a catch-up mode. So I think it's really, really determining what's going to be IP for your organization and worth investing in. And then do you have the ability to hire those? And the truth is that, it's a reality that Google can hire a different set of engineers than a bank can, that a IT company can, that a consulting company can. And so really looking and being honest with yourself, am I going to be able to hire and retain the talent necessary to continuously building out infrastructure, or should I buy infrastructure from wherever and focus my time on building the models and the IP where I can create? And that's a decision that you have to make kind of internally as to like where your organization lies.
Okay, great. Rajiv, anything to add to that?
Yeah. So look, I think like you need to decide what your core strength is, right, and what the IP is, right? Like, do you really want to build like an Uber Michelangelo like parallel platform, or you want to actually partner with which would not be your core strength? Or you want to partner with vendors and product, right? And get some product where you can have a scalable machine learning platform. Same with models also. Like the way I have approached it in the past is like, what is the IP we are generating, right? If it is if something which we are working on, or the data scientists or machine learning engineers are working on, which is going to become a core IP, so definitely you want to keep it in-house, right? But if it's something which is generic and you really don't have an IP base over there, would you be better off buying something and increasing the speed to market? So I think it's person to person and company to company, but you should go back and look at some of those things and say, okay, how can I increase the speed to market and at the same time protect my IP and make sure that whatever our core strengths are, we play to that.
Okay, great. We have a question which I'll ask while we're doing this next poll. Where someone's actually asking, you mentioned speed to market, but they're asking if there's anything specific to machine learning they should highlight to the executive team other than the business value it will generate. So is it scale, speed, efficiency, new markets they can break into, that sort of thing. While we'll start with Diego on that, but if everyone could take the poll while we're going through the answers to that, that would be wonderful.
Yeah, I think like, look, highlight at the end of the day, if you're building around, it's fairly easy to show good results with machine learning if you're actually building around what you're optimizing. So as I said, when you can actually go and say, hey, we invested in this machine learning model to do kind of like upsell, and that upsell model is now doing $6 million a year. These are like very tangible business outputs that you can actually like focus on, and that will in turn, allow the organization to continue investing in it. It's the truth is that like, every year there's going to be a budgeting process, and when that budget is being, delved in, like how much investment is going to be done into machine learning and AI. The more direct results, start small, show results, build upon that, is going to allow to, the bigger increase and, investment in that area. And so my recommendation is always start with very, very tangible, direct, like results that you can actually show, even if they're small, and then build upon that. And that's the best way to actually get buy-in from leadership, because they can actually see the investment going into results and building out, versus trying to kind of take a more boil the entire ocean at once approach of we're just going to try to apply ML to everything in the organization at once.
Okay, great. Rajiv, anything to add to that?
No, look, like if you can get it, it's really good. But I've never seen it happening that you go to executive management and say that, oh, I need $5 million or $10 million because I want to put together a machine learning team. I mean, at least I've not seen it happening. If you can get it, that's wonderful. But typically, right? So the question is that mainly it starts with you take these use cases, right? Coming back to initially what we were discussing earlier is you need to actually define properly what you are trying to achieve, right? Like take it small, right? Small use cases, prove them out, show the value of it, and definitely executive management will support it. But the key is to actually start small, build these use cases, whether it's efficiencies. I think the question had some about efficiencies or new revenue streams or whatever it is. So you can always prove out those use cases starting small. I think once you prove those out, then you can actually go in, get funding, and actually build upon it.
Great, thank you. And it looks like, once again, the panel has, the folks out there listening have kind of reflected what you both said. It looks like in the majority of cases, we have multiple people responsible for ML. So anything you can do to help build consensus there is probably a good thing. Great, so now let's talk about specifically what makes financial services special. So Diego, we have a number of financial services clients here. How is the industry different? We've talked about, kind of the similarities that we all share, but what is it about financial services that makes machine learning either tougher or just, unique?
I think, regulation is one of them. So it's interesting because financial services has actually been, we talk about a couple of industries that have kind of been at the forefront of machine learning, and I would argue that it might have had a different name and a different aspect, but using kind of like statistic quantifiable methods in a predictive way as part of decision making has been something that financial services approached for many years now, decades at really. And so there's a little bit of a first mover advantage in the sense that the concepts are not new. I joke around, we used to call them quants, now we call them data scientists to a certain degree. The flip side of that is heavily regulated. So compliance and understanding like what those regulations are from a government perspective, oversight, what can and cannot be done, what data can and cannot be used. These are all things that add a level of complexity to the world of financial services. So you have this, you kind of have this like yin and yang going here, which is you have an industry that has probably approached this and has the most experience in approaching this kind of problems for the most years. So you would think they're the ones that could like jump into this at the highest rate and speed, yet they have this, for very good reasons, this giant regulatory and compliance burden that kind of like slows them down into what they can approach and they can't approach from a machine learning perspective.
Okay, Rajiv, would you like to add something to that, and then also take question number 2 about what the early and common use cases are?
Yeah, sure. So see. I don't feel, at least my opinion is that it is not very different. Financial services, like if you take pharma, for example, they pretty much deal with the same kind of issues or concerns they have around regulation, and they've been doing a lot of work about predictive modeling and all that for ages. So it's not a whole lot different. I think where the difference I see over the last like 7-8 years or five years, I would say, is that I think they're getting more and more aware of what machine learning data science is bringing to the table, right? So it's no longer the research papers or only Google and Microsoft or Facebook are doing some of this work. So certainly, people both in financial services or even in pharma, they're realizing that the power of machine learning data science can be harnessed on the financial services side, right? So a typical use case, and a lot of banks have started to do that, is around gaining efficiencies in their operational models. I think that's a very, very common use case, which everybody's trying to do, right? On operations side, ingesting a lot of faxes, ingesting a lot of PDFs, documents, emails, classifying them, things like that, right? So that's one common use case where all of a sudden everybody's realizing that, okay, they can do more, right? So I don't know, 8 or 10 years ago, right? Everyone started with automation. Automation was big, automating the entire workflow pipeline. But now the data science has come in, which can actually generate more value than just saying that, okay, automate this whole process. They can actually better that process which used to exist, right? So that's very common use case, which I've seen across the board. Another use case is looking at alternate data sets, right? Especially for portfolio managers and investment side, right? So you're seeing a lot of these use cases where people are starting to use these machine learning models either to predict the outcomes or even to model some of the portfolio behavior. So off late, you're starting to see a lot of banks and especially in financial services, people starting to actually use machine learning data science more and more heavily.
Okay, great, thank you. And our third bullet is compliance. We actually have a question on that, which I think we definitely need to throw to you, Rajiv. The specific question here says, traditional models for banks are covered by Fed SR 11.7 model risk requirements in the US. Are these requirements considered during the development of ML models?
Okay, so it's I'll give you a very kind of funny story about it. So a couple of years ago, when we started with these models and all, right, so somebody came back to me, oh, we need to put this, there was a compliance system. We had to, where all the financial models will go in. So somebody came in and we had developed a machine learning model. And somebody came back to me and saying that, oh, we need to put this model in that system, right? Because we need to make sure that it is compliant and all that. And I started going through the questions. I can tell you that most of the questions were not relevant to what we had done, right? So the point I'm trying to make is compliance is definitely very valid, right? But I think this is one area which is still catching up in terms of model development and what we are actually doing in data science, right? So still there are systems and processes are not in place yet to have these models be regulated in the system, or where people can go in and see that what the model is doing or answer some of these questions. And one of the reasons being that a lot of cases, all these models are black boxes, especially to the legal team, right? So they're trying to get answers to some of these questions which they have. So what we end up doing is taking those models and converting back to the business issues, business problems, and actually letting the compliance and legal teams know what this model is trying to achieve. So there is still, I feel, what I've seen is there's still a gap between how we can actually put these models in the existing compliance systems and make them compliant as far as legal and compliance teams are concerned.
Great, thank you. I'm going to skip straight to the Q&A here because we have just a couple minutes and I want to make sure we can answer at least one more question. And again, we have a few questions we probably won't get to, but we can follow up with you on email. We have your information and we will get back in touch with you. And we'll also have contact information at the end of the webinar. The question is, we're currently working on using NLP to extract valuable data points from deal documents. Would you recommend building these NLP tools internally or outsourcing them from third-party companies that could cost over $100,000 a year? Diego?
Yeah, I guess the question is, do you have are these NLP tools really very specific to your company and your use case, or are these NLP tools kind of like more generic? That would be my first question that I'd try to answer. Second, I would say, the price, $100,000 a year, like, I don't know if that's expensive or cheap, right? Because if those tools can provide you with an upside or savings of $1 million a year, of a $2 million a year, the amount of money really sounds irrelevant at that point. So I think, again, tying back to what the business result is going to be of the effort actually puts into context where you should do it. The fact is, what's going to get you faster there? So if you're saying, hey, we believe that these NLP tools are going to be able to give us business optimization that's going to result in a surplus of a couple $1 million a year, then my argument would be, what's the fastest path to that? Is that fast path to go and outsource this with a good partner, understand how they're building it, pay for it and get there quicker? Or is it worth spending a little bit more time building in that muscle internally potentially and bringing in those NLP experts in-house, knowing that they're going to be extremely expensive, knowing that you're going to have to constantly evolve on those, and your organization today might not have the structure or infrastructure to be able to support them. So these are kind of the questions that I would ask myself around doing that. There's no right or wrong answer in this particular case. It's really about, where do you think, Rajay said it himself, where do you think your specialization is, and where do you bring, what is going to be your secret sauce internally? Is it the actual NLP methodologies, or is it the decisions that get made with those NLP methodologies? So if it's the decisions that are being made, then why not outsource the NLP methodologies as quickly as possible, get over that so that you can spend most of your time on the making decisions with it. That would be how I would approach it.
Hey, Rajiv, anything to add to that before we wrap up?
No, I think it's the same. The build versus buy discussion, it's always tough, but you do need to look at how much you're willing to spend, what your IP is, what you're creating, and what the benefit is. I mean, I can't comment on the 100K thing. It all depends upon how much value you're getting out of it, right? So, but I think the more important point, which Diego also touched on, is that what you're trying to achieve with it, right? If you are able to, if you do spend that money and you're able to build a solution or whatever you're doing in a week or 2 weeks, versus you do it by yourself and you have to now stand up the whole team. And by the way, it's not easy to build this whole team and build these models, right? So it all depends upon what you want to get out of it, right? So that should drive your decision.
Okay, great. And we actually have a last-minute flood of questions here, so I'll try to squeeze in one more. This should be a quickie. Have banks started implementing quantitative ML explainability frameworks for deep learning models, or is it only for simpler ML models? Diego?
Yeah, so I'd argue that explainability frameworks for deep learning is very much in research academic stage at this point. I think you're going to start seeing some providers that are going to provide explainability at the process perspective, but really anything that has to do with real explainability inside what's happening inside neural nets is, at least in what I've seen, is mostly still research. And we'll see that over the next couple of years really evolve. Explainability around kind of more traditional heuristic models and logistic regression models that we do see frameworks in financial services. A lot of this stuff, again, is the same explainability requirements that were required for logistic regressions and model risk management being applied to kind of slightly different use cases, but we see a lot of those being implemented. And it's interesting because a lot of these have been mostly kind of workflow or checkbox based from a compliance perspective, but we're seeing a lot more automation being built around it.
Great, and we're actually at our time right now. We've got some links up here. If you'd like to learn more about Algorithmia, please, if you're at the AI for Finance show, stop by our booth. Additionally, if you'd like a demo, we've got a link there where you can find it. We have a white paper on the 7 challenges of ML for DevOps, and an email address if you'd like to follow up with more. But I'd like to thank our speakers and thank our friends at AI4 for letting us do this today.
Cormac, great work moderating. Diego, thanks so much. Rajiv, thanks so much. See you at AI4 Finance, and have an awesome week, everybody. Thanks for joining.
Great. Thank you so much.
Thank you.
Thank you so much.